Ready? Oh, good afternoon, everyone. I'm Thomas from Skyline Communications. First presentation after lunch. I hope you don't fall asleep. I want to talk about the Elastic Media Facility, how to efficiently orchestrate media workflows end-to-end. That's really from when you plan and schedule orders, events, productions, up to an automated and orchestrated event execution. Most important thing first, what is orchestration? People use the same word for many different things, have different understandings. What is it not? It's not only signal switching in IP. It's also more than automation. Automation, at least our understanding, is to execute a script, a series of tasks at a certain time. It's more like fire and forget. And what orchestration is to us is much more of a framework or an architecture, still to automate, but the life cycle of an event and service. It has a time component to it. It's time aware. Important, this is an end-to-end thing across multiple technology domains. Most important here, we need to manage resources. When we say orchestration, it's all about managing resources. And an orchestrator needs to keep in mind availability of resources. Is it available or booked or not booked? Pretty simple, probably. Needs to know about the capabilities. Can my video server do HD or UHD? How many channels, etc. But also needs to be aware of capacity. How much bandwidth do I have when I need to connect some media functions? When we talk about orchestration, you might have heard about the word lifecycle service orchestration, often called LSO. On the right-hand side, there is a pretty simplified lifecycle for a production. Can start with planning, then you need to deploy your infrastructure. We have heard about this today. Once deployed, once it's up and running, you need to still configure it. Then you monitor and control it. That's when you actually run the production. And at the end, you need to deconstruct your infrastructure again. Just a couple of aspects here. What's important when we talk about LSO, you have different teams involved. You have the scheduling team, you have the MCR team, you have the operations. At different steps or times of the events of the productions. We talk a lot about administrative data here as well when we talk about lifecycle service orchestration. And that data typically gets gradually collected. You might have the first person just entering high-level data, start time, stop time, what kind of production, give it a name and an ID, and then you hand over to another team. They add more data to it. And that gradually gets added over time until you run the production. And that handover between those different teams or those steps, they need to be managed. Managed means you need to be guided as an operator. It needs to be a pretty strict workflow where each and every operator needs to enter exactly that data that you need later on to move on. And it's often a combination of what we say manual and automated steps. A manual step can be an approval process. That's something you cannot automate. There is your manager. He has to hit the button and say that's approved or rejected. A pretty simple example for automated steps is resource reservation. That's something you can perfectly automate. And when you reserve resources, you also need to orchestrate and connect the resources later on. And when you think about what we have heard in the morning already, cloud-based or cloud-ready productions, you need to support events that vary and evolve over time. It's not always the same thing you do. Instead of just reconfiguring, that's what we do today a lot, it's about redeploying infrastructure a lot. Resource reservation, let's have a bit of a closer look today on what that is. In the past, you see that on the left-hand side, it was a lot about offline planning. A lot of broadcasters, media companies, they work with Excel sheets. That's like the grid. That's where you plan your resources. Or you have scheduling tools, but this is all offline tooling. You might use tools like Schedule or anything similar than that. Those are offline tools. You have a set of, let's say, 10 encoders. You need 2 for the next production. Well, that's easy. 8 are left. You can still use those. It works pretty well when you are in a hardware-based world, but when it comes to a more dynamic world today, and we see here this, what we call infrastructure as code, you cannot work with those offline tools anymore because there is nothing like a fact that you have 10 encoders or so many video servers, you have 0, because you need to deploy them later on. So that whole concept of offline planning and then working towards your production doesn't fly anymore. And it's not only like those on-demand resources. There are other use cases, dynamic use cases, plant maintenance, much more mandatory than it was in the past. In the past, you were deploying your infrastructure, you were running it, and people said never touch a running system. That was good for many years. Now you are forced to do updates every now and then, and pretty often, because there are security breaches. Your vendors call you, and you need to do plant maintenance. Plant maintenance means resources are not available for a certain point in time. Also incidents, failures, etc. That adds a complete new set of dynamics. And what we need to do then is combine those two worlds to say offline planning needs to go away over time. It needs to be all in a single orchestration platform to automate the whole part, to say from an assisted, automated, up to a fully orchestrated way to resource, to manage your resources over time, over that life cycle. What does it mean? In fact, you cannot really split those two worlds anymore from the scheduling team towards the operations team or teams in the MCR. That needs to go together. We have heard a lot about why going to the cloud today. Already, I don't want to spend too much time on that slide. It's really about cloud helps you becoming that elastic media facility. There's a lot of pros. You go to the cloud, you can easily scale, you can go to market with new ideas, you bring the right talents together. We have heard about this today, but why is it that people just don't do it right now? To us, and we spend a lot of time with that in the company, we always say it's easier said than done. Cloud migration is more than another technology migration as it was in the past when we went, for example, from SD to HD, which was mainly about replacing technology, but not so much about replacing anything else. When you look here on the right-hand side, how did we work for many years was more in a waterfall method. We were planning, we were installing, deploying, we were running our systems for 5 years or longer. We operated, then we do the same thing again. Doesn't fly anymore. In that more agile world, what we say, you need to run every cloud project or all those new projects as a digital transformation journey or project. And what is digital transformation? I like the definition of being capable of dealing with change easily and efficiently. It's not so much about being super fast, but you need to be able to deal with change. There's a lot of surprises out there in our world. Nobody has foreseen COVID. Nobody has foreseen the war in Ukraine. So things happen unexpectedly. There's uncertainty out there. And that's all about that digital transformation. And that involves changes in technology. So you need new toolings, you need new tools, but also, and that's important, you need to train people and you need to introduce new methodologies. And methodologies is a lot about becoming an agile operation, going away from that waterfall method. And you might have heard about DevOps, CI/CD, CO, continuous integration, deployment or delivery and operations. Instead of doing that waterfall project, you need to do a never-ending circle. You operate, you evolve, you create, and that never stops. So it's not like a traditional project management anymore. And as a media company, like many other companies, also in other industries, we all need to become a more software-driven organization or powerhouse. And a lot works in the way that we need to digitize and automate workflows. That's really key. So automation is there all the time. So why don't we just go there? It's about problems we might see. And biggest problem is we have too many analog workflows. I like that one on the left. So there is pressure, we have heard it. When you put pressure on people, there is room for mistakes. They make mistakes, they don't like that. To reduce the pressure a bit, it helps a lot when you automate those repetitive workflows. When you help them guide people, they need the right tools. Less pressure helps a lot. And there are simple things like I always use that example, and we heard it from a lot of customers when we do some investigations on costing, on cloud and other infrastructure as code experiences. It's super easy to turn on cloud instances or any other tools in software, but people just forget to turn things off again. Happens to me as well. When my boss calls me Monday morning, Thomas, do you still need those 5 instances? I said, no, but I burned some money. That just happens, it's natural. Also, interesting fact, there is no guarantee that cloud instances and resources are always available. You need to consider that. Cloud is not something which is there and there is no unlimited resources. It can happen that you run out of certain resources in the cloud. APIs are more complex. It's not just MIP files like in the past with some SNMP. You have RESTful APIs, they're constantly changing. There are proprietary standards, which is good, but also you need to consider that, like CDI, we have heard it today, perfect. But what if you want to move to another cloud system? You need to think about it. Lack of multicast PTP support, I don't want to go into all details here. Sometimes a simple fact, not easy to access. You cannot walk into a room, go to your hardware panel and just operate. You have to enter a URL. Not always you know the URL. It's simple things like this where we've seen operators complaining that they can't access their tools. Also the control interfaces in software, yeah, it's new. It's not for people that have used classic hardware panels for many, many years that they easily adapt to software panels. The risk to have a vendor login or a single cloud provider login is still there, like it was before with traditional hardware vendors as well. When you look into cloud management tools, that's another challenge. They don't support on-prem equipment because that's not part of the cloud. And then less of a technical challenge is the lack of confidence. That is really a shift in mindset when you run something in the cloud or everything is cloud-based, that a couple of hours before your production starts, none of your equipment, none of your media functions you need exist. And people need to get that confidence, they need to get the right trust to say, I need to trust automation, I will trust my systems that when I start my production, everything will be ready. What we have done, and I don't want to go into too many details, is an example or a joint collaboration with Grass Valley, with GVM and also third-party interfaces. 15 minutes left, thanks. To do a demonstration or a sample application, IBC last year, I guess, was the first time we have presented that, to show that complete workflow, to have interfaces where people can enter the production data, start time, stop time, what kind of production, small, mid-size, tier 1 production. And Data Miner, that's the product or the framework we are building in Skyline Communications, was spinning up then the right instances, was booking the right resources, connecting them together with some third-party applications like the RTS intercom there. Today I want to talk more about how is it done. That's all about that CI, CD, and then CO experience. And what we have developed internally with our platform is a couple of key tools. One is called object modeling, the other one is called service templates, and that's what I want to talk about briefly today. What is object modeling? Object modeling is to, maybe similar than an Excel sheet at a first glance, to manage administrative data. But you need to define a data model first, because every customer, every media house has a different set of data. And what we are doing, we built that, what we call data miner object modeling, that allows people to define their own objects. And an object is, first of all, to gradually add admin data. And that can be something simple like this here. You have a definition, that's important. You just define what kind of information do I need to run my production. Can be something simple like the name, start time, stop time, optional mandatory fields. And when you then enter data and fill it with data, then you have an instance. Important here, what we do, we link each and every object later on to a certain production type. And that's a list of predefined service templates. I will also talk about that. So that you have admin data, and based on the admin data and the production type, you know what to do and what to automate later on with those service templates. Most important here, or the biggest difference to like an Excel sheet, because you might think you can do this with an Excel sheet as well, is that it's state aware. What we can do here, we can define states. That's important when you do lifecycle service orchestration. And here is a simple production example where we have a couple of states. Those bubbles here in the middle, the first state might be draft. You just enter a few core data, my production name, start time, stop time. That's a user entering the data. Maybe even some resources he might select already. Then there might be a simple approval process in between. Once approved, it goes into confirmed, and only then you can deploy the resources. Then your actual production starts, has a start and stop time. At the end, you need to spin down the resources again. After you have deployed the resources, you certainly need to configure and connect all your media functions. And at the very end, you need to free up the resources and also keep track of the utilization of the resources for the billing. And when you look into such a workflow with all those states, it's a mix of automation and user interaction, but it's all guided. After each and every state, you can run automation scripts. One example could be when it's in confirmed, we deploy resources. That's pure automation. Data miner automation, spinning up resources in AWS or spinning up resources in the private cloud, then configuring those that can be automated. An approval process is probably a manual process, but also guided. Somebody needs to approve it. If not approved, the workflow won't move on. At the end, it must be guided and very well defined that people can't work around that and cannot be creative at the end to do something out of those boundaries. Service templates. What is it when I have defined my administrative data? Somehow a system like Data Miner needs to know what to do with it. And there we map service templates to that administrative data set. What is a service template? First of all, it's defining building blocks. So you don't have to think about any vendor you are using or any technology you're using. All you do, you define building blocks and say, on our very simple example here, I need some JPEG XS encoders, I need a couple of video players, a multi-viewer, a video mixer, I need an output. I also need people. Those are resources. I need some intercom panels. Doesn't really matter yet here if it's on-prem, off-prem, or which vendor it is. It's independent of the underlying technology. That's how you define it first in Data Miner. You specify those functions, the connectivity, and some dependencies. In a second step, you need to link functions to resources, because at the end, there must be some real resources behind each and every function. And then you also have so-called profiles, and we apply profiles to resources. For example, you need to configure your player in HD or UHD. That's a profile. How do we technically do it? And that makes it vendor independent or multi-vendor capable. Those profile parameters, we need to translate them into vendor-specific API calls. When I have a JPEG XS converter from EVS, there's a different API call required compared to a JPEG XS converter from Grass Valley or any other company out there. That's what we call mediation, by the way, those translation from those multi-vendor profiles into the vendor-specific API calls. What we also do, we work with resource pools. So you have a profile, that's what we briefly talked about already. And when you look into a building block like a JPEG XS converter, where a profile might include, that's a bit simplified here for sure, parameters like bitrate, the format, the JPEG XS, profile as such, maybe a sender IP, a multicast IP I want to apply to my JPEG XS converter. That's what we do in a profile. And then we map those to resources from resource pools. But resource pools, remember, can be from different vendors. They have, again, an availability. It's free, it's reserved, it's in planned maintenance, or maybe it has an error, I can't use it. They have a capacity and they have capabilities. And those can be different per vendor, per brand, maybe per version, per firmware, whatever you have out there. Capacity is often the network interface bandwidth. But also software licenses, don't forget about those. More and more is software-based. You might have a, what is a good example, a multi-viewer with 20 inputs. The very same multi-viewer is licensed with another license to have 40 inputs. You need to know about that as an orchestration platform. And then capabilities can be anything technically, but can also be something like a location. If I need an encoder in Stadium A, a system like DataMiner needs to know that this encoder physically sits, or the compute platform, in my Stadium A, and not in Stadium B. What is the challenge here when we talk about the resources? In the past we had physical resources, my 1RU box. It was running 24/7. Now in software-based world, it's different. There are dependencies. When you run the media function, what we call the production resource, where we apply the profiles, you first need to deploy the contributing resources. There is a concept that we say we need to build that north-south stack. A contributing resource might be an FPGA. We need to reprogram an FPGA. Here is an example from Lavo. That's a V-matrix chassis where we need to reprogram the FPGA there to be either a H.264 encoder, JPEG XS encoder, or any other function you can have there. Or it can be spinning up a virtual machine, spinning up an EC2 instance, or run a microservice first before you can configure the actual production resources. And those dependencies, you need to be able to manage those in an orchestration platform. Looking back into our lifecycle management system, it's more complex in reality than what you see here. What we have seen here so far, we deploy the contributing and production resources. We have our service templates. We manage the production from start to stop. We spin them down again. But when you look a bit more into details, an approval process is not always straightforward. What we call a manual process here. And that's again a bit simplified, but I guess you get the idea when we say, I need to approve it. Well, it can everything, all information can be there, can be just perfect, or it might be incomplete. We might be required to edit some information before I can approve it, but I also might have to reject it. What am I doing when it's rejected? I can say, okay, then my automation is over, my workflow is gone, but that would be a bad idea. So it goes into a pending state in our case here. Pending state means I might have to send it back to another team to change a few things. And only when it's approved, then we can add automation again to reserve my resources. Another example here is the start and stop of my production. Production is always more than a simple start and stop. You might have things that are in standby, then it's running, then it's paused. But what are you doing, for example, when things break during the production? We have here a default state which is called quarantine. And when something goes in quarantine state, because one of our encoders or video servers breaks, you need to find an alternative. That can be a different resource you need to spin up. Can also be to apply a different profile, because I don't have an UHD resource anymore. I might use an HD resource as a backup. Or I need to reschedule. So that's also something you need to automate again. At the end, that service lifecycle orchestration is not only about managing like the default workflow. I guess 80–90% of the work what we are doing goes into managing those exceptions to make sure you don't stop the whole workflow when things don't go as ideal as it should be. In the last couple of minutes, I want to talk about the CO part. And there we have something what we call low-code apps, low-code applications. What is a low-code app? Or why low-code apps at all? Those are apps, user interfaces that are easy to design and build. Means we don't have to have C++ or C# coders. It's people like me. I don't have a developer background, but I can build my own application for one specific target that different people need different user interfaces. And that's something what we try with what we call low-code applications. It's all HTML based. To have the right interface for the right people, we say at the right time. A couple of screenshots there from that Grass Valley demonstrator we have built on the left-hand side. You see a user interface, a bit small with a timeline. where you see the complete schedule of all your events. Then there might be specific user interfaces, pretty simple here, to load a different clip on my clip layers. This is all GVM stuff. Or we just embed existing user interfaces, in that case from Grass Valley. Or we run software-based UIs from third parties. There's no need to reinvent the wheel. When there are existing UIs already from the vendors, then we can just embed them. In case customers need something more simplified, that's often a reason, we can build a specific UI for them. Low-code applications, that's key. They follow, again, CI/CD principles. What you see here, when you go into edit mode, you have a drag and drop UI. Again, you don't need to code and redevelop the wheel. You can do this at runtime, change, evolve over time. You hit a few buttons, and then you have a new version. In CI/CD, it's key that you have different states as well. That's in draft. I can test it out. If I like it, you publish it. Everybody can use it immediately. And if it fails, you go back. We heard it today, I guess, a couple of times. You need to fail quickly. If you fail, there is a way back. At the end, 30 seconds, sorry for that. How do you run that? You need to transform the company or into an elastic media facility. How do you do that? Treat everything, as we say, as a digital transformation project. And that's technology. You need different tools, but don't forget about people. We have started that internally in our company a couple of years back. It's a lot of education required, and you need different methodologies. That's a lot about becoming agile. And with that, I was overrunning a bit. Thanks very much.